Everything around us is made of tiny particles called atoms. Think of atoms like Lego blocks. Now, imagine different kinds of Lego blocks, each with its own special properties. That's what chemical elements are. They are the fundamental building blocks of matter. Each element has a unique atomic number which tells us how many protons are in its nucleus. For centuries, people didn't know about elements. Ancient Greeks thought everything was made of earth, air, fire, and water. But over time, scientists started experimenting. They discovered new substances that couldn't be broken down further. These were the elements. One of the earliest breakthroughs came with the discovery of oxygen. Can you imagine a world without oxygen? We need it to breathe. Then came the realization that carbon is essential for life. It's the backbone of DNA, the blueprint of life. These discoveries were just the tip of the iceberg. As scientists delved deeper, they found more and more elements, each with its own unique story to tell. Let's talk about oxygen. You can't see it, but it's all around us. Take a deep breath. Feel that. You just inhaled oxygen, and your body needs it to survive. Oxygen is a colorless, odorless gas that makes up about 21% of our atmosphere. Without it, we wouldn't be able to breathe. Plants and trees are amazing. They release oxygen during photosynthesis, the process they use to make food from sunlight. Isn't that cool? But oxygen isn't just about breathing. It plays a vital role in many other processes. Ever seen a fire burn? Oxygen is what keeps the fire going. It's also used in hospitals to help patients breathe and in rockets to launch us into space. Carbon is a very special element. It's the key ingredient in all living things on Earth. From the tiniest bacteria to the largest whale, carbon is there. It's like the Lego block that connects everything in the living world. Carbon can bond with other elements in countless ways. This allows it to form long chains and complex structures like DNA and proteins. DNA carries our genetic information, while proteins do all sorts of important jobs in our bodies. But carbon isn't just found in living things, it's also in diamonds, the hardest natural substance on Earth. And guess what? The graphite in your pencil lead is also made of carbon. It's amazing how versatile this element is. Gold, the very word evokes images of shimmering treasures and ancient civilizations. For centuries, gold has been prized for its beauty and rarity. It's found naturally in its pure form, which means it doesn't tarnish or corrode. That's why ancient gold artifacts still gleam brightly today. But gold isn't just about its looks, it's also incredibly useful. Did you know that gold is used in electronics? It's an excellent conductor of electricity. And because it's so malleable, it can be hammered into incredibly thin sheets called gold leaf. These sheets are used to decorate everything from furniture to chocolate. From ancient tombs to modern technology, gold has left its mark on human history. It's a testament to the enduring allure and versatility of this precious element. Section 5. Decoding the elements. A look at the periodic table. Imagine a giant chart that organizes all the known elements in the universe. That's the periodic table. It's like a giant map that helps us understand the relationships between different elements. The periodic table is arranged by increasing atomic number, which means each element has one more proton than the one before it. The elements are also organized into rows and columns. Elements in the same column, called a group, have similar chemical properties. For example, the far right column contains the noble gases, which are all very unreactive. The periodic table is a powerful tool for scientists. It helps us predict how elements will behave and how they might interact with each other. It's like having a cheat sheet for understanding the building blocks of the universe. Section 6. Elements in action, real-world applications. Elements are everywhere. We've already talked about oxygen for breathing and carbon in living things, but let's explore some other amazing ways we use elements in our daily lives. Aluminum is a lightweight and durable metal used in everything from soda cans to airplanes. Copper is an excellent conductor of electricity, which is why it's used in electrical wiring. Silicon is a semiconductor, which means it can conduct electricity under certain conditions. This property makes it essential for computers and smartphones. From the cars we drive to the medicines we take, elements are the unsung heroes of our modern world. Section 7. Fascinating tales from the world of elements. The world of elements is full of fascinating stories and quirky facts. Did you know that the element mercury is a liquid at room temperature? That's why it's used in thermometers. And here's another fun fact. Helium, the gas that makes balloons float, was actually discovered on the Sun before it was found on Earth. Scientists observed a strange yellow line in the Sun's spectrum and realized it belonged to a new element. These are just a few examples of the intriguing and often surprising nature of elements. There's a whole universe of chemical wonders waiting to be explored. Section 8. The Alchemist's Dream, Synthesizing New Elements. For centuries, alchemists dreamed of transforming ordinary metals into gold. While they never quite achieved that goal, their experiments laid the groundwork for modern chemistry. Today, scientists are realizing the alchemist's dream in a different way, by creating new elements. Using powerful particle accelerators, scientists can smash atoms together at incredible speeds. Sometimes these collisions create new, super-heavy elements that don't exist naturally on Earth. These elements are often very unstable and decay quickly, but they provide valuable insights into the nature of matter. The quest to create new elements is a testament to human curiosity and our desire to push the boundaries of scientific knowledge. Section 9. Elements and the Future Shaping Tomorrow's Technologies. As we delve deeper into the world of elements, we unlock incredible potential for future technologies. Nanotechnology, for example, involves manipulating materials at the atomic level. This field holds promise for breakthroughs in medicine, electronics, and energy production. Scientists are also exploring the use of elements in renewable energy sources. Solar panels, for instance, rely on silicon to convert sunlight into electricity. And researchers are developing new battery technologies using lithium and other elements to power electric vehicles and store renewable energy. The elements that make up our universe hold the key to addressing some of humanity's greatest challenges. By understanding and harnessing the power of elements, we can create a brighter and more sustainable future.